Yeah, so hello everyone. My name is Malik Arslan Nisar and I am the TA for this course. It is our second live session and we shall be discussing some more questions regarding to the topics you have studied during the week. So if anyone of you wants to summarize what you have done in the previous week, anyone? Any volunteer?
From previous tutorial, yes, you are asking from previous tutorial.
No, not previous tutorial. Obviously, what the
Um,
content you have studied during the week.
During the second week, it's
Yes,
a
the
second
second
week
week.
portion.
Yes.
Okay. Second week portions are linearly dependent independence.
Ha. Linear independence, dependence,
Mm,
and I think basis and dimension. That's
basis
all
and
that was covered.
dimensions.
Right.
Yes.
Yes, yes. So, how many of you have
And
solved?
linear transformation and also linear transformation.
Yeah. And
Mm.
so, how many of you have solved the assignment of second week or even tried to solve it?
Yes, ma'am.
You tried attempting it? Have you done it?
Yes. Yes, ma'am.
So, you
Yes,
got.
ma'am. I tried and done.
Okay, okay, fine. Then, and the previous first week assignment, have you done that?
Yes, yes,
Yes.
So all of you have done the first week assignment
yes,
also.
yes.
But there is some doubts. Shall
Um,
we discuss?
Actually related to assignment one, I do not have the access to new assignment of yours. And do you have other regular TAs for the course? Because like I have been instructed to show some sample problems, then you have to do the assignments. And I think there might be some discussion from or other TAs who would be discussing the doubts because in every session we are required to do the sample problems related to second week, not to the first week. So that's why I'm sticking to that. But if time permits, we can discuss your doubts. You can let me know the problems or you can share them with me. I will try and solve them, and after that, we can discuss. Is that fine?
Okay, no problem.
Okay. So, since you have studied linear independence dependence during this week, so I want you all to solve the questions because I was thinking that the second assignment of yours I have gotten that we can solve some questions of that also in the class for your practice because you won't be getting maybe much time or maybe some people skip the assignment, they don't solve it. So that's why I want that we discuss some questions of assignment 2 also, that would be helpful to you also, and some sample problems I have gotten, they would also be helpful for the assignments. So the first question is, let u is equal to 2 0 minus 1, v is equal to 3 1 0, and w is equal to 1 comma minus 1 comma c, where c belongs to r, that is the set of real numbers. The set UVW is a basis for R3, that is the three-dimensional real space, provided that C is not equal to option A -2, option B 2, option C 1, option D 0. So is my screen clearly visible to you? The question
Yes,
here,
yes.
the question is that we have three vectors u, v, and w, and the value of c is not given, but we have been told that c is a real number, and we have also been given that the set UVW, it is a basis for R3. So, do you all know what is the basis? What do you mean by basis? Any one of you wants to tell me what a basis means?
May I?
Yeah, sure, Kavita.
Okay. So first we have to check it out. The vectors are linearly independent.
Yes,
Then it spans the whole R3 whole
yeah,
space.
yes.
That's the true
So,
condition for checking basis.
yeah, you're correct. So, what is a basis? A basis means it is a set of vectors. If it's every, like we say, if we have a vector space V and there is a set of vectors, ठीक है, set of some vectors say B, and this V can be completely gotten by the elements of B only, and it should be like the minimum number of vectors which are linearly independent and span the whole vector space. As Kavita said, that was correct, that from these vectors we can get the entire vector space V. That is the basis. For your like reference, I can say like we have the three-dimensional coordinate space, correct? I, J, K. I take this example because it gets simple, because we can imagine in 3D, and apart from that 4D, 5D, that gets difficult to like visualize. So the easiest form is to visualize in 3D only. So here vector I, J, K, they are linearly independent and they form a basis. Why? Because in 3D, if there is any vector given, I give you any vector in 3D, you can get that by the combination of I, J and K. How that? Like you can write it as alpha I plus beta J plus gamma K, right? That's why we say that this is a basis. So now the question here is that for we have given a set of vectors u, v and w, and it has to be a basis for R3. Like for the three-dimensional space, it should form a basis, provided that the value, what should not be the value of C. So any one of you tried this question? Like you can try it in a minute and tell me the answer, otherwise we'll discuss it.
Answer -2.
Yeah, -2 is correct. Anyone else tried it and got the same answer or any other answer? Then we can discuss it. Because as I have mentioned, you guys have to do it. You can consider this as a practice session. You come with a pen and notebook and you try to solve here, because that will give you practice. Maybe since this is an online course, you might have other work, or sometimes you will not be able to solve, or sometimes you skip the class. But if you join the live session, that will give you this advantage that you can solve meanwhile in the class. This will be a 2 hour practice session, and people are still joining. And yeah, that's why I want you to guys at least solve during this session. Don't sit and watch it. Okay. So the correct answer is -2. What we will do here, since we know that these three vectors have to be linearly independent, 2, 0, -1. The second one is 3, 1, 0, and 1, -1, and C. These have to be linearly independent, and that also implies that we can make the, if the three are linearly independent, the determinant is going to be 0. So we will write 2C, like determinant is not going to be 0, so 2C minus it's 0. Then here we can do 1 into -3 minus 1 is equal to 0. Correct. If the determinant is 0, that means it's not linearly independent. And C, here we get 2C plus 4 equals to 0, which gives us the value of C equals to -2. correct? So understood this part? Then we can move to the next question. If you want, you can note it down as well. Then we'll move further. Understood this question? Guys, at least respond that should I move further or if I have to explain anything. Or you
Understood.
huh. So okay, moving to the next question. Uh, ठीक है. We have a question. What is the dimension? You can note along with me. What is the dimension for the general solution W of the homogeneous system x1 plus 2x2 minus 3x3 plus 2x4 minus 4 times x5 equal to 0, 2x1 plus 4x2 minus 5x3 plus x4 minus 6x5 equal to 0, 5x1 plus 10x2 minus 13x3 plus 4x4 minus 16x5 is equal to 0. So note this question and you can give it a try. After that we will discuss the solution. The question says that we have to find the dimension for the general solution of this homogeneous system. Homogeneous system means that the right hand side is 0, and for this system we have to find its dimension of the general solution. Some people are still... Okay, anyone wants to explain how we can proceed with this question? Yes, Kavita.
Just write it in a matrix form, coefficient matrix.
Yes. And
Then make it to the row reduced echelon format and
yes,
find the rank.
yeah, that is how we can do it. So do you
By
guys want
seeing
to try
itself,
it?
it is a yes. I'm trying. By seeing itself, it is a three equations with five unknowns. So two free variables. So among our remaining three, we have to check it out.
No, no, there will be 3 free variables, not 2.
Yes.
3 will be free and 2 will not be free.
Remaining for dimension, I think rank, finding the rank, is it correct?
No, finding the rank is like you have to find the dimension, like as you said earlier, that we have to find that how many of these are free variables and how many are not free, because the free variables will give you the dimension, because the rest we can form from them only. What is the dimension? First of all, we will discuss what a dimension is. We can you tell what a dimension is, any one of you? Kavita, you say what is a
Num,
dimension?
number of elements in its basis.
Ha, the number of vectors in its basis, like the minimum number you need to get the entire span, correct? So that is the dimension. And the dimension of general solution we can find by like I will tell you how to do it. We can simply first find its row reduced echelon form. Correct. Can you find its row reduced echelon form? First, we
Doing now.
might do R2, since here we already have a 1, like reading and leading entry is 1. Then we can do R2 is equal to R2 minus twice R1 and R3 as R3 minus 5R1. It would give us something like 1, 2, minus 3, 2, minus 4. So help me in completing this. What will this element be? It would be 0. Here also R2 minus twice R1, it's 0. Minus,
1
yeah, it would be 1. The next one would
minus
be
2
minus 3, correct.
2
Then it would be
2
yeah, it would be 2. And what will the third row be? It will be 0,
0 0 2
0. Yeah, sorry.
minus 6
This one would be 2, this one would be minus 6, and this one would be 4, I guess. Right?
4. Yes, 4.
Yes. After that, what we can do is we can find see here you can see okay, we can do R3 as R3 minus twice R2. You can simply see it's the double of it, correct? 1 into 2 is equal to 2. 3 into 2 minus 3 into 2 is minus 6. 2 into 2 is 4. You can clearly see here only that this row is dependent on, like the third row is dependent on second row. That's, we will get this as 1, 2, minus 3, 2, minus 4, 0, 0, 1.
தம்பு என்ன பண்றா போச்சு.
So here the entire second row, third row becomes 0, and the first two row you can see that they are linearly independent, right? And we can write them as x1 plus 2x2 minus 3x3 plus 2x4 minus 4x5 and x3 minus 3x4 plus 2x5 equal to 0. Now, since we have 5 unknowns and only 2 equations, right? We have 5 unknowns, but the number of equations are 2 only. So what we can do is that we can get only 2 variables out of it, because we have 2 equations. You might have studied earlier also that the number of equations give you the number of solutions. If there are lesser number of equations and more number of unknowns, then you cannot find the solution. Here also similarly, there are only 2 equations which will give us 2 variables, say x4 and x5, and the remaining 3 we can represent in terms of, like we can say x1 is equal to k1, x2 is equal to k2, and x3 is equal to k3. So these are our free variables because we are going to choose them, and thus we can calculate the values of x4 and x5 depending on them. That is why we say that dimension of the general solution will be 3. That is x1 equal to k1, k2, k3, because they will be 3 vectors, right? From them we will get this solution, because x5 and x4 we will get from this only, but those 3 vectors we will have to choose. Those are the free variables, and since they are free variables, that will be giving us the dimension of this general solution, and that is why it is 3. So how many of you have
Actually, how you select its x3, x4 and x5? Madam?
we can select anyone. It's your choice.
Like, okay. Any 2 we will be, any 3 we will be choosing. Any 3 can we choose?
Yeah, we can choose any 3, because see, only 2 equations are there, right?
Okay.
We can express two variables in form of other three.
Okay.
Here I
Okay.
said x4 and x5. You can say x3 and x4.
Okay.
Because in second equation, see, if there are x3, x4, x5, you can choose any one, and you can express the other, like you can express 2 on the basis of other 3. And that is
Okay.
how you get the dimension.
Okay.
If there would have been more number of equations, if there would have been 3 number of equations, then the number of free variables would be reduced. But here, since there are only 2 equations, that means 2 we will get from these equations and other 3 will be free. What we say linearly independent or vectors. So that is how the dimension is going to be 3. Understood this one? You can note it down for your reference. I will wait. Should we move ahead?
Yes.
So let's try this question. Yeah. Consider the following linear transformation. The linear transformation. Please note along with me so that you can get time to solve also. Consider the linear transformation T from R4. Wait a second. Yes. R4 on real numbers given by T of x, y, z and u equal to x, y, 0 and 0. Then you have to say which of the following is correct. A part is rank of T is greater than nullity of T. Second part is nullity of T is greater than rank of T. C is rank of T is equal to nullity of T, which is equal to 3, and another one is rank of T is equal to nullity of T is equal to 3. So please note down this question, then we will move to the solution part.
3 and 4 same.
Huh? Oh, sorry.
Options 3 and
Sorry,
4
sorry.
same.
Yeah, sorry. This is going to be 2. Rank
2.
of T is equal to nullity of T is equal to 2. So, we have discussed in last class also what a linear transformation is, and you might be well aware with rank and nullity, right? We have discussed what null space is, what nullity is. So the question here is that we have been given a linear transformation which is mapping from two 4-dimensional spaces of real numbers R4 to another set of R4 only, given by this, right? We have been given T is x, y, z, u equal to x, y, and like you can express it as uh, we have been given this as x, y, 0, 0. So it will be 1, 0, 0, 0. Y is there and rest are been given 0. Correct. So the linear transformation or the matrix has been given as this, and now they are asking about rank and nullity. So anyone got what is the solution of this one? What should be the solution of this one?
Last.
Huh?
D. D answer. Rank T equal to nullity equal to 2.
Yeah. See, it is very simple. You can clearly see, you don't have to
Yes.
perform. It's
Simple.
already in RREF form, right? Since this is in
Yes.
RREF form already, we can clearly see what the rank is. Rank is equal to
Uh,
2.
2. Number of
And
linearly
nullity
independent rows.
is, yeah, nullity is also clearly visible as there are 2 rows of zeros. But there is another theorem you should always remember, that rank of a matrix A, here rank of a matrix T, and its nullity is going to be equal to the number of rows or columns, whichever is lesser, right? Here they are both are equal, number of rows are 4, number of columns are 4, so whichever is lesser, rank plus nullity is equal to that only. Here we got rank is 2, so nullity is also going to be 2. This was simple, right? Nullity will also be equal to 2. So I think there should not be any doubt in this question. We will move to the next one. Are others also solving along with me or only Kavita?
Yes, ma'am. Solving.
Solving now, you should also answer. So the question number 3, which one should we discuss? Yeah. So consider the real vector space R3. Consider the real vector space R3. The following vectors form a basis S of R3. What are the vectors? U1 equal to 1, minus 1, 0. U2 equal to 1, 1, 0. And U3 equal to 0, 1, comma 1. Now, the coordinates of V equal to 5, 3, 4 relative to the basis S is. So, have you all noted down?
Yes, yes.
Huh. So the question is asking us that we have a real vector space R3. You can consider as the coordinate space XYZ. And the following vectors, like that only, it consists of the basis system of these three vectors, U1, U2 and U3. Like we in coordinate system, we have uh, 0, 1, 0, 1, 0, 0, then 0, 1, 0, then 0, 0, 1. Similarly, this basis system is formed of U1, U2 and U3 which have been given. Then it is asking us that say there is another vector V with coordinates as 5, 3, 4. So what will be its coordinates relative to the basis S? They are given the absolute coordinates. So what will be the coordinates of V in the basis system S? That is what you have to find. Understood the question? Or should I repeat the question? Because first you should understand the question, then only you can move to the solution part. So the question is clear to everyone?
Please repeat, ma'am.
Yeah. Okay. See here. The question is telling us that we have a real vector space R3, the three-dimensional space, right? Consisting of all the real vectors and the basis. We already know what a basis is. Basis is the minimum number of linearly independent vectors we need to span the entire that vector space. That means उस वेक्टर स्पेस में, इफ यू आर कंफर्टेबल विद हिंदी, उस वेक्टर स्पेस में जितने भी वेक्टर्स हैं, ऑल दोज वेक्टर्स विच आर included in that vector space, you can get them by the linear combination of these three vectors. जैसे हमारे पास ijk होता है in the 3D space, जो xyz coordinates हमारे पास होते हैं, यूक्लिडियन स्पेस हम जिसको बोलते हैं, उसमें हम लोग i, j और k कैप के मदद से कोई भी वेक्टर ला सकते हैं, है ना, by the linear combination of this vectors. We have हमारे पास होता है 1 0 0 0 1 0 0 0 1, ठीक है, यही तीन वेक्टर्स होते हैं, ठीक है, इसको मैंने इस फॉर्म में लिखा है, लेकिन ये ऐसे तीन वेक्टर्स होते हैं, ठीक है, आई कैप, जे कैप और के कैप होता है. इन तीन वेक्टर से वी कैन गेट एनी वेक्टर इन द, इन तीन के लीनियर कॉम्बिनेशन से वी कैन गेट एनी वेक्टर इन दैट स्पेस. इतना समझ में आ गया? सो सिमिलरली यहाँ पे जो गिवन है u1 u2 एंड u3, एंड उनके कोऑर्डिनेट, मतलब उनकी कोऑर्डिनेट्स ऐसे गिवन है आपको, ठीक है, u1 इज इक्वल टू 1 -1 0, u2 इज 1 1 0, u3 is 0 1 1. So this is also forming a basis. From this you can get any vector in this space R3. Now it is asking for the coordinates of a vector v which is like 5 3 4 relative to this basis. मतलब इस basis में इसके coordinates क्या होंगे? That is what you have to find. Now you understood the question?
Yes, yes.
Yeah, the question is clear. So you can take a minute and tell me the if you are getting the answer or if you are stuck anywhere. Anyone who is trying it, or how should we do it? Any suggestions? Any?
Form the transformation matrix and with this base vectors and multiply with this vector.
Yes, I think you are doing it correctly. See, it's simple. We have been given the vector 5, 3 and 4, right?
Yeah.
This is our vector. And it is telling us that we have to express it in relative to the S basis. So simply, if our S basis is U, formed from U1, U2, U3, it is going to be a combination of, a linear combination of them, right? Alpha U1 plus beta U2 plus gamma U3, correct?
Yeah.
This we can simply express as 1, U1 is what? 1 minus 1 0, 1 minus 1 0, then u2 is 1 1 0, so 1 1 0, and u3 is 0 1 1, correct, multiplied with alpha, beta and gamma. It is equal to 5 3 and 4. Now what you can do, you will multiply them and you will get 3 equations, right?
Yes. Yes.
And you will get the values of alpha, beta and gamma. Can you quickly solve this and tell me what are the values you are getting?
3 to 4.
3 to 4. Wait, let me check. Yeah, 3 to 4 is the correct answer. So anyone else got it? So see, it's very simple. Alpha plus beta is equal to 5. Then we have minus alpha plus beta plus gamma equals to 3. And third equation we will be getting gamma equals to 4. So gamma we are getting from here Putting it in equation 2, we get minus alpha plus beta is equal to minus 1. And what we can do here, simply we can add the first equation with this third equation, right? This is 1 and 2. Adding 1 and 2, what we get? We get twice beta is equal to 4, which implies beta is equal to 2. And from equation 1, we get alpha is equal to 5 minus beta, that is 2, which is equal to 3. So yeah, 3, 2 and 4 is the correct answer. So how many of you got this right?
I got that.
Okay. So do you need time to copy it or should I move further? Okay, we can move to the next question. Uh, I think we can discuss some questions of your assignment. Is that fine? There
Okay.
are 10 questions in assignment 2, right?
Yeah.
So we can discuss some of them, and if you have already done it, that is good. Otherwise, you can get help from this also. So, do they upload the solutions? I mean, the answer key of the assignments regularly? Like, have you gotten the answer key for first assignment? Is it
Submission date is not all, ma'am. It's 7th only.
okay? It's 7th only. For first assignment, also the submission date.
Yes. 2 assignments is 7th.
Okay, okay. So, still 7th Feb, you have to submit assignment 1 and 2, right?
Yes.
Okay, okay. Then after that, they will release the answer key for your check, like for your reference, right?
Yeah.
Okay, okay. So, ठीक है, we can. You all have the assignment on your end, right?
Yes.
Okay. So you can open it and let's see question number 1. I have to also first. Second. Yeah. Hello. Am I audible and visible?
Yes.
Yeah. So what the first question is telling us, let V is equal to R4 be a 4-dimensional real vector space, and let S1 comma S2 be the subsets of V such that S1 is equal to U1 comma U2 and S2 is equal to S1 union U3, where you have been given U1, U2 and U3. U1 is equal to 1, 2, minus 1, 0. U2 is equal to 0, 1, 3, minus 1. And U3 is equal to 3, 4, minus 9 and 2. Then there are certain options mentioned that S is linearly independent but S2 is not. S2 is linearly independent. You guys have the assignments on your end now, or should I write down the statements also?
It's there.
So S2 is linearly independent, but S1 is not. Third option is that both are linearly independent, sorry, linearly dependent. And the fourth option says both S1 and S2 are linearly independent. So, how many of you have tried these questions? How many of you have tried attempted the assignment too? It's not necessary that you have solved all questions, but at least given it a
I've
try.
tried. Okay.
Huh?
I've tried. I've tried it.
Okay. So, you are, what's your good name?
Gifty.
Okay.
Gifty, ma'am.
Okay, Gifty, you have tried it. Kavita has tried it. Anyone else has tried it? So you can give it a try here also. Huh. So, Kavita, what answer did you get?
First answer, S1 is linearly independent, but S2 is not.
Yes. And can you explain why?
Um, S2, which is nothing but U1, U2, U3. Just form a matrix and find the determinant value.
Yes,
Uh,
that is how you do it, because when you for the case of like S1, you can clearly see that U1 and U2, they are linearly independent among themselves, right? You can
yes.
see that, and that is why S1 is linearly independent. But when you form S2, it consists of C. The solution is that S2 is going to be something like 1, 2, minus 1, 0, 0, 1, 3, minus 1, 3, 4, minus 9, 2. Correct? Or you can write it the other way around, but the rank is anyways not going to change. So we can do it like this only. So
Yes.
can you find the rank, because we have already done this? So quickly tell me the rank of this. Like,
Row
get the row
reduced.
reduced echelon form. Try to get it.
Row reduced.
Yeah. So what what linear what row transformations will you perform here? Gifty and Ronak, are you trying?
Yes, yes.
Yeah. Tell me what is the matrix, what linear transformation you are sorry, what row transformation you are performing and what are you getting? See, the row transformation is that R3 will be nothing but R3 minus 3
Three,
times
three
R1,
hours.
right?
Yes.
And in that
Yes.
manner, you will get, this will remain same, these two rows. Then the third row will be 0 and 4
Minus 2,
minus, yeah, minus 2,
minus 2,
minus
6,
6, I think
plus
minus 6,
6.
yeah. And this one is
No,
going to be
plus 6.
plus 6. R3 is minus 9, then minus 3. That will be plus 3. It will be
Okay,
minus 6, na?
minus 6. Yes, yes, sorry.
It will be minus 6. So we can perform another row transformation, but you need not do that. You simply can see that R3 is nothing but it is just the twice of R2. Can you see it? See, 1 into 2 is equal to, uh, no, wait a second. 3, 2, yeah, minus 2, minus twice of second row. If you multiply minus 2 with second row, you are going to get third row, right? And you can see,
Yes.
can you see it?
Yes.
Yeah. So that is why this third row, it is going to vanish and there will only remain these two. So it means it is not linearly independent. So S1 is linearly independent, but S2 is not. So option 1 is correct. Understood?
Yes. Yes.
You can perform that also. You can simply do R3. gives again R3 plus twice R2, right? And it will give you 1, 2, minus 1, 0, 0, 1, 3, minus 1. This is 0, 0, 0, 0. And this is the, from here you can conclude that S2 is not linearly independent. So you noted this down?
Yes, yes.
Okay. Now we can do, I think, I'm not able to access your assignment, so I have taken snapshots. We can do question number 3. I don't, yes, huh. So question number 3 we can discuss, because question number 2 seems to be similar, right? It's again on linearly independent, two vectors, subsets have been given S1 and S2. So I want you to try it on your own. Is that fine? First question I have shown you.
Yes, ma'am.
Similarly, you can do second question.
Yes.
Then we can move to third question. It is related to dimension again. So should I start discussing this one? Anyone wants to read it out for me? Ronak, you? Because I want to
Let
see if
V
you are
be a
mentally
real
present
vector
here.
space.
Huh.
Let V be a real vector space and S be a subset of V containing n vectors such that L bracket S is equal to V, where L bracket S represents the linear span of the set S. Then dimension V is equal to n,
Huh.
dimension V
No, no need to read the
smaller than n,
options.
dimension V.
No need to read the options. So did you understand what the
Okay.
question is asking you? It is telling us that there is a real vector space V, and here I will show that there is a real vector space V, or maybe I'll write the question because I have to share these notes for your reference. So I will quickly note it down. Meanwhile, you can think over it, you can give it a try, and then we will discuss. Let V be a real vector space and S be a subset of V containing n vectors such that, this is the condition given, such that linear span of S is equal to V, where Ls represents linear span of set S. Now it is asking about the dimension of V. So I want the answer from you guys because we have discussed just a question based on dimension. So please put your answers in chat box. What do you think is going to be the dimension of V? Is it going to be equal to n, less than n, greater than n? Okay, Kavita, you are telling it's n. Who else is telling that it is going to be n, less than n, or greater than n? Anyone else? Ronak Gifty? Any guesses? At least you can guess. Wow. See, here you have nothing to solve. It's just a question of intuition. We are given that,
Same.
huh? Okay, your answer is same, right? So, okay, since you have gotten it, but I'll still discuss it. It is telling us that there is a real vector space V, and there is one subset S, such that the linear span of S like the linear span of S gives us V. What does that tell us? That the like from the subset S we are getting the whole vector space V. Correct? It is what it means. That means it represents a basis. The S is a basis for V. Is that correct? It is telling us that the linear span of S, the subset S, is spanning over the vector space V. That means the number of vectors, as it is given in question, that there are n vectors in S. So all those n vectors are going to be linearly independent and they are going to span over the vector space V. That means the dimension of the vector space V is going to be n only, na? Like, understood?
Yes.
Like, as I
Because
always
it's
said
a
that you,
basis.
huh? Yeah, Kavita, you're saying
I
something?
said yes. I said
Ha,
yes.
ha. So
Yes,
you can
yes.
always imagine and compare it with 3D coordinate system for your understanding. Ronak, did you understand this question? Or do I need to repeat it? Ronak, are you still here?
I understand.
Okay, okay. So we can move to the next question. Question number 4. So the question number 4, Kavita or Gifty, you can read it out.
Let V is a vector space of dimension R in a range R, be an n-dimensional real vector space. That S is a subset of this vector space Rn. We define as S equal to A1, A2 up to An, and where this obeys a condition A square is AI minus 1, where I is 2 n and A1 is 1. The dimension of the span of S is given the options.
Okay. So did you understand what the question is telling? If you understand, then you can share it
Yeah,
with
the
the...
span of S we have to find first
No.
of all. So the dimension of the span of S is the question.
Okay, wait a second. So here again the question is based that we have a vector space V which contains which is n dimensional vector space. Okay, it's not 3D. Here you can see that the superscript of R tells you about the dimension of the vector space. It is an n dimensional vector space. Okay, and then we have been given that S is a smaller subset of this vector space, and in that we have the elements a1, a2, and so on up to an, correct?
Yeah.
And
Yes.
by the definition we can find out them, right? Here it is given a1 is 1, then a2, what will be a2? The value of a2 is
Choose plus or
again
minus 1.
so that is again coming out to be 1.
It is
And
actually A square, madam.
yeah,
A2
it
is
is ai square, because see,
A2 square is 1. So A2 can be plus or minus 1. That's it.
Plus or minus 1.
Plus or minus 1.
yeah, it
Because
can be
A2 square is 1.
it can be plus 1 or minus 1, but if you see, then for the next element it
Next
will
one.
come out to be imaginary, and
Oh,
in the
okay.
question it has been given that it is real, so you cannot
Yes.
consider minus 1. That's why we'll discard that. It can have both values, you are right in that, but when you calculate the next element, that will come out to be imaginary, which we do not want because it is real. It has been given that it's a real vector space. That's why we discard that, and all these elements are coming out to be 1, correct?
Yes, yes. Okay.
Okay. So now what is the dimension of S? You can clearly see that it is 1,
1.
correct? So the dimension
Yes.
of span of S is 1. So had you gotten it right?
Yes.
Yes, ma'am.
Yes.
Okay. Ronak, you also understand, na? Okay. So, ठीक है, then there is question number 5. It is again on dimensional space. Question number 6, 7. Okay. We can do question number 6. Do you want to try it on your own first? Question number 6.
So option 2.
Huh? Option 2. Who is telling that? Gifty, you.
Yeah.
Have you tried it?
Yes.
Okay, Kavita, what is your answer?
It's the same answer only, but once again, please explain, ma'am.
Okay, okay.
Because I simply substitute U1, U2 in the given thing and get the
Yes,
answer.
yes, yes, yes.
But
You
I
have to
need
do
the
it that way
explanation.
only. Yes, that you have to
Yes,
do
but
it
I
that
need
way.
the explanation why we are doing like that.
Okay, okay. So, Ronak, you have tried it? Huh. Okay, fine. Then I will repeat it. See, we have been given that V is a vector space of R3, right? It is a three-dimensional vector space. Wait a second, let me write it. Three dimension. Have you gotten the link to the previous like notes of the class?
No.
Okay. I have uploaded them in the presentation folder. I think you might get them shortly. With respect to the basis B are given as U1B is equal to 1, 2, 3, U2B is equal to minus 5, 2, 0 respectively. Then coordinates of 5U1 minus 3U2 with respect to the basis B is. See, the question is telling us that we have a vector space V, three-dimensional vector space. Again, I'm telling you for your reference, you can imagine the 3D space, the Euclidean space in your mind. And then the coordinates of U1 and U2 with respect to the basis B are given. Correct? There is a basis system. Basis means that the entire span can be gotten with respect to that basis. From that basis, we can span the vector space. That is U1 and U2 are given. Correct. Now you have to find the coordinates of 5U1 minus 3U2. That is why you are simply substituting U1 and U2. Because like in the previous example also, as you remember that we had to find what was the previous question? Huh. When we had to find that the coordinates of V, which was given 5, 3 and 4 in the with respect to the basis S, there we simply wrote that it is going to be some alpha times U1 plus beta times U2 plus gamma times U3. Similarly, the coordinates of 5U1 minus 3U2 with respect to basis B will be by substituting U1 and U2 because they are spanning the B, na? That is why any linear combination of them, here we have to find 5U1 minus 3U2. That is why you will simply substitute it. I hope that answers your question, Kavita. Or what is your doubt exactly?
Okay, ma'am.
If there is still confusion or you were trying to get something else, you can ask. So you will simply
No,
do
ma'am.
5. Huh?
I just do this thing only, but
Okay, but
I'm
you
not
were
sure
not
why we
sure
are
if
doing
you're doing
that.
right or not.
Why we are doing this way? I'm just confused.
You're still confused.
No, 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 no,
Okay,
ma.
now you are clear, na?
Okay. Okay.
Okay, okay. So that is how you get it. So, Ronak, you understood? And Gifty, you?
Yes, ma'am.
Yes, yes.
Okay, okay. So, question, how much time is left there? We can discuss question number 9 and 10. After that, maybe if we get some time, we'll practice something more. Or you can tell me about your previous doubts. So, question number 9. Anyone wants to read it out? Kavita, you?
Yes, ma'am. Let V and W be any two finite dimensional vector space over the field F. Let the transformation T from V to W. Then four transformations are listed out.
Huh.
We have to check it out which one is linear.
Yes. So, as Kavita told that we have given four transformations, like linear transformation का definition given है, that t of x is something that has been defined in the question. Then what you have to check, that you have to check which of the following transformation is linear. Like some of them may not be linear, some of them may be linear. You have to check that out. Since you have assignment on your end also, I will give you 2 to 3 minutes to check it. Meanwhile, I will note down the question. So, Ronak, Gifty, you can also give it an attempt. And Kavita, you have tried it already, right?
Yes, ma'am.
Okay, okay. So, let V and W be any two finite dimensional vector spaces over a field F, and let a transformation T from V to W, then which of the following transformations is linear, right? So we will discuss them one by one. It is V, it is W. ठीक है? V is a vector space, a real in like a real vector space, and W is also a vector space. Yeah, it is from real numbers only, no? Now it is given it's two finite dimensional vector spaces, and the transformation has been given as T. Now it is asking that which of the given transformation will be linear. Firstly, we have been given that V is equal to R, W is equal to R, and then T of x is equal to cos x. Here in the first option, V has been given as a one dimensional vector space of real numbers, right? समझ लीजिए एक axis, it has been given as a axis. W is also similarly given as an axis, just one dimensional, and the T of x is cos x. See, it is clear now because cos x cannot be linear. It will not follow the linear transformation. So you do not need to see further. If you can see cos x, sin x, functions like that, you can clearly see it will not be linear, right?
Yes.
So the first option is not linear. Now, moving to the second option, we have been given as V is equal to R square, right? V is a two-dimensional space. W is also equal to R square, and T of x comma y has been given as x plus y comma 2, correct? So what about this option? Kavita, you had tried it? Do you think it's linear or
Yes, ma'am.
yeah,
Not
not linear? And how is that so?
It's
first. We have to say when you say the linear transformation, basic definition is it satisfies three conditions. First one is t of 0 equal to 0.
Yes.
And next, the linear combination, or else we can say t of x plus y equal to t of x plus t of y. Then scalar multiplication, alpha x equal t of alpha x equal to alpha into t of x.
Yeah.
The first condition t of 0 equal to 0. That condition itself, our first thing t of x equal to cos x also ruled out, and the second one also ruled out
Yeah.
because t of 0 not equal to 0 for this two.
Uh, yes, t of 0 is not equal to 0, but mm, yes. You can do it that way, but uh, here I think t of 0, yeah. The linear
T
transformation
of
here,
0 comma
huh,
0.
see, the linear transformation here is given as t of x comma y is equal to something like x plus y and 2, right? The t of 0 is not satisfied here because you are going to get
2, 0,
0 comma 2.
2.
So that is why this is also not a linear transformation. But for your understanding, I am telling if there were say, yeah, no,
Cons.
I think this much is only sufficient here. We can deduce by this condition only. So the third part, in the third part we have been given as t of x comma y comma z, right? It has been given as x
X
plus
plus
y comma
plus
10
Z.
z. So in this case, is it satisfying or not?
Yes.
Is it
Yes.
Yes,
is
linear.
it satisfying? Yes.
Yes.
So here you can see that t of x comma y comma z, it has been given from R3 to R3, right? And the definition is x plus y and 10z. Now we have to check it. For this to be a linear transformation, the first two conditions are satisfying. Now we have to satisfy the third condition. T of 0 is 0, right? That condition is
Yes, ma'am.
satisfying
Yes.
here. Now the third condition is that T of, if we have like like v1 and v2 in suppose transformation v1 comma v2, in earlier class also we discussed that t of alpha v1 comma v2 should be equal to alpha times t of v1 plus alpha times t of v2, right? Or maybe beta times. So this condition should also be satisfied here. So wait a second. You can note down this solution that yes. Now if I am putting t of alpha x comma alpha y comma alpha z, it is going out to be alpha times x plus y, right? And 10 times alpha z. And I can simply take alpha out, right? And it will be x plus y and 10z again. So this condition is satisfied. So this is a linear transformation, right?
Yes.
Yes,
Yes.
ma'am.
Now moving to the fourth part. The fourth part is okay. It is from let v is equal to r3 and w is equal to r2. Then t of x comma y comma z is given as, the definition is modulus of x plus y and
2.
2z. So what about this condition? Is this a is this a linear transformation or not?
No.
Huh?
No,
No.
No.
And how can
no,
you prove
not
that?
linear.
Yeah, how can you prove that?
Because modulus of x plus y is less than or equal to mod x plus mod y. So
Yes.
inequality is
Yes,
not
yes.
satisfying.
This you can simply understand by intuition, but for the proper procedure, we can simply say that if I put alpha x, alpha times y, alpha times z, right? It is going to give me modulus of alpha x plus y, modulus of x plus y, and here we will get twice alpha plus twice alpha z. Now here you can see what is the value of modulus of alpha. Modulus of alpha will be alpha when alpha is greater or equal to 0, and it will be minus alpha when alpha is less than 0. Correct? That times you cannot take alpha out, because here it will be minus alpha, but like here it will be minus alpha and its modulus will be alpha, and here it will be minus, right? So it will not
Yes.
be equal to same. There will be a sign difference in both of them. So this is not a linear transformation. Understood?
Yes. Yes.
Yes, ma'am.
Ronak, did you understand? Hello, Ronak, are you there? Yes. So you can note this down. Then we can move to the 10th question, or maybe we can take a 5 to 10 minutes break.
No break.
Okay, you don't want break. Kavita really enjoys doing maths. Is that
Yes.
so?
Should not
Yes.
waste time.
Huh?
Jyoti don't want to waste time.
Okay, you want to completely finish the session and do your work, right?
Yes. Yes.
Kavita, you're doing PhD in which stream?
Uh, Actually, non-linear differential equation in shift dynamics models.
Okay, like what is your
So for
background
shift dynamics,
basically? Like the broad sub, like which branch?
actually for shift dynamics models, roll motion controlling, I just find the
No, I
develop
understand
the
that. I mean, like, what is
algorithm
the
based
department?
algorithm.
What is
Where
the
you are doing, ma'am?
huh?
Where you are doing? Which institution?
I am in IIT
The,
Kanpur currently.
Oh no, not ma'am. Kavita ma'am.
Okay.
I'm from Tamil Nadu, ma'am. You are Jyoti or
I
from?
am from basically Tamil Nadu. I am living in Trivandrum. I am working in ISRO and
Okay,
doing my PhD in IAST, Indian
okay.
Institute of Space
And
Science and Technology.
okay, okay. Actually, I'm doing here at Shastra Private University.
Okay.
So, should we discuss question number 10 now?
Yes.
Okay. So, Kavita, you can read it out, or maybe Gifty or Ronak, you can.
Yeah. Let V is a three-dimensional space, real vector space, and the transformation is from V to W be a linear operator defined in V, such that the transformation x, y, and z is given by x plus y minus z, and x plus y plus 2z, and 2x plus y plus 3z. That's a
Okay.
question.
So, did you get the idea what the question is asking? Ronak, you say what the question is asking us to find? Okay. Kavita, you?
Linear transformation is given when they are asking the question regarding rank and nullity of that transformation.
Mm-hmm. So, how will we do it? We have done it previously, right? We did
Yes.
a
Yes,
similar
yes,
question in this session only.
yes.
So,
So for the linear transformation, I just try to write a matrix
Yes.
So
Yeah, yeah.
then
That
I'll find out the
is how
kernel.
you that is how you will do it. So first of all, for
Using
your reference, I will first explain the question, then we will discuss the solution part also.
okay,
So here we have been given that V is a vector space, but it is in three dimension, right? It is a three-dimensional vector space again, and then there is a transformation T from V to V, right?
Yes.
A transformation V has been given from V to V. By transformation, I explained in first class also that a matrix is also called a linear mapping or a linear transformation, right? So that is that this is also a linear transformation defined on V. And what is the definition of this transformation? That T is equal to x plus y minus z, x plus y plus 2z, and 2x plus y plus 3z, right? This is the definition, or this is the like output which we are getting from the transformation. Now it is asking for the rank and nullity. Now to simply find the rank and nullity, what we will do? First we will find the rank of this transformation. Then from the rank nullity theorem, we know that rank plus nullity is equal to minimum of the number of columns or rows, right? We did it in previous question also. So here also what we can do, we can write this transformation simply as 1 1 minus 1. Then the second row will be 1 1 and 2. Then the third row will be equal to 2
Two,
1
one,
3.
three.
And this is like this, we can express it like this. So can you quickly find the RREF of this and tell me what is the rank? Quickly you can do it. It is a simple matrix. And if you are studying like linear algebra and matrices, you should have a hold on like quickly finding the rank and everything. Like you should practice it. So Kavita, you are getting 3. Others, can you try it? Try to get it in RREF form. Gifty and Ronak, did you calculate the rank? Okay, doing now. Okay, you can take your time. Why are you guys taking so much time? It's very simple.
Two.
You are getting 2. I guess you have done something wrong, or maybe Kavita and I have done something wrong because I also got rank as 3 when I was calculating and I don't have the solutions. So, can you tell me how did you get rank as 2? Which vector, which row you got as 0?
Last.
Last. No, I don't think you will get that 0. Because see, any linear
I'll
combination.
check, ma'am. I'll check
Ha,
once again.
you check it once. Ronak, what did
Okay.
you get? See here, simply we can subtract row 2 from row 1. We will get 0, 0, and this will be 3. Correct? we can simply do here row 2 gives us row 2 minus row 1, and for R3 we can get R3 minus twice R1, correct? So R3 minus twice R1 will give us 0, minus 1, and 3 minus it will be 5, correct?
Fine. Yeah.
So here only itself you can see we have a 1 0 here, 1 here, 0 here, 1 here, 0. So these three are linearly independent because you cannot like further get any combination from, like you cannot combine two of these rows and then get the third row. It is clearly visible, right? Sometimes you
Okay.
have to use the intuition also.
Okay.
Fine. So the rank is going to be,
Let's find for the finding determinant itself. You can easily find out that.
sorry, what?
This is 3 by 3 matrix. That's why I just find out the determinant. So that's enough.
Indeterminate, yeah, simply that is also one way. But in determinate, what we can, like in determinate, we can just conclude that if determinant is not equal to 0, then all three are linearly independent. But if that is 0,
Independent.
yeah, if the determinant is 0, then maybe 1 or maybe 2 or
We have to do.
any number
Yes.
of rows can be like linearly dependent. But since
Yes.
here it is a 3 by 3 matrix, you can simply find determinant, and if the determinant is non-zero, you can do it that way also. If the determinant is non-zero, which you will get in this
Then
case, it means all three are linearly independent. So what is the determinant you got, Kavita?
3.
Huh? Yeah, determinant will be 3.
Determinant
See,
value is 3.
if you here also see from column 1, you can get determinant as 3 minus 0, right? And determinant would be 3. It is a non-zero. That is why all the three like rows are linearly independent. That is why the rank is
Independent.
also 3. Correct? And about nullity, simple, we know that rank plus nullity
Equal to
is equal to 3,
dimension
right?
of that domain.
So from here,
So that
nullity
will be 0.
will
0.
be 0, right? And
Yeah.
that is not given in any option. So the rank is going to be like 3, and that is the correct option. So I think we have discussed most of the questions. I think 2 or 3 will be remaining that I want you to try on your end, right? And then submit the assignment. Do you have to submit a written copy, or you just have to like click
With
the
online options, we have to select.
okay, you have to select options and then you will get it, right? Fine. So have you submitted assignment 1 and 2, or you're
It's
still
submitted, ma'am. Second is
Submitted one.
okay? One submitted, right? That is good. Ronak, what about you? Have you submitted assignment 1? You can try to do it as soon as possible because yeah, okay, if you have done, that is good. Now I think we have still some time left. So do you want to practice some more questions, or should we end the session because like we have reached the end of the assignment?
that question 5.
Question number 5, I have not tried it on my own end because I thought it was similar. Wait a second. Question number 5. Uh, we can discuss it in the next class maybe because
Okay.
see, now there are only few questions remaining, right? 2 or 3 questions. You should at least try them on your own end.
Sure.
If you haven't attempted yet, it won't make sense. So in next class we can discuss this. So I think I will give you some of 1 or 2 questions, but you all three of you should do it in the class only for the practice purpose, including you, Ronak. So I will give you a matrix C. We have a matrix A, 2, 4, 10, 3, minus 7, 11, minus 1, 4, and 10. Now you have to determine whether these three vectors are linearly independent or not. The way Kavita said in the previous questions, that if we found out the determinant, and like I will explain here, if we find out the determinant, there are possibilities that the determinant will be equal to 0 or the determinant will not be equal to 0, correct? If the determinant is 0, what does that suggest?
Dependent.
Dependent, correct?
Yeah.
If the determinant comes out to be 0, it suggests that there are some dependent rows. If the determinant is not equal to 0, what does that suggest? They are linearly
Independent.
independent, correct? It suggests they are linearly independent. But if the determinant is equal to 0, it will suggest that there is some linear dependence, but it will not suggest how many rows are dependent, right? There might be 2 rows dependent, or if it is a huge matrix, all the rows can be dependent, or even if one row is dependent, it determinant will come out to be 0. So this will not give you the number, right? In the previous question you did not require number, so you got it with this also. But if you need exactly how many linearly independent or dependent vectors you have, for that, how you will proceed? You will simply again do the RREF and then find out whether all three are linearly independent or not. So can you try this on your own end right now in the class, all three of you, and tell me what you are getting? You have to tell me how many linearly independent or dependent vectors it has. Are you doing it?
Yes, ma'am. Yes.
Okay. Ronak, you?
One independent is the last row.
Only last row is
Last
dependent,
row.
right? Wait, let me check the answer. So you got the RREF?
Yeah.
What is the matrix you are getting?
1, 2, 5. Then
No,
0.
I think you have done something wrong. Yeah, what is the matrix you got?
1, 2, 5.
Wait a second, let me write it down. You're telling me that you got something like 1, 2, 5.
Yes.
And
Then 0,
then
0,
huh
minus 1,
huh
minus 19, 1, 9.
minus 19. So you subtracted 3 times of this.
Yeah.
Okay, but you subtracted row 2 from this, so 0 minus 3. Okay, subtracted reverse. 1 minus 3, then 2 minus this
I
is
think
equal to,
second row is wrong.
yeah, 2 minus, yeah, it is wrong, right?
0, 0, minus 13, minus 4.
Minus 13. Yeah.
Yeah, so yeah, this is wrong. So that is
The right answer is
uh-huh.
the right answer is
What? Did you get it?
right. Uh, Second row right entries are first row is okay. First row correct.
Second is
Did you get the answer? I'm just erasing it. Did you get the answer? Like, did you get the RREF?
I'm doing.
You take your time because I just want it for your practice.
Okay.
Ronak, are you trying? Did you reach somewhere? Okay.
Zero, 1,
Yeah. So you got
1.
what?
Yes, ma'am.
Uh-huh.
What you wrote is correct.
No, no, I wrote it because it will take a lot of time. That's why I want you to give me the final answer. The
Okay.
final your
That
opinion.
final answer.
Yeah. The
First row,
final
1, 2, 5.
1 to 5.
Yes.
Okay. Second row, 0, 1,
Huh?
4 by 13.
4 by 13. And
Yes.
third?
Third row, 0, 0,
Huh?
218
218
divided by 13.
divided by 13.
Okay.
So, can you simplify this further? This is the final you're
No.
getting.
Yes. This is a final
Okay.
RRF.
I think you have made some mistake.
Okay.
So, because finally it is going to be coming out like an identity matrix. That is why I don't know where
Yes,
you.
R3, in R3 it is only one term. You just divided it. 1.
Uh,
R3 divided
yeah,
by 218 by 13.
yeah,
That,
you can.
that's all.
Yeah, you can do that. But then this and this is not zero, no? Okay, this will be 210
Not
5.
identity.
It will
Not a
not be
bracket.
identity, right? It is
Yes.
coming out to be identity. I don't know where you guys are doing it wrong. So should I leave it as a homework because it is,
Identity,
Okay, okay.
huh?
Okay.
they are
Yes.
trying, they are not converting RRF. They trying to a diagonal matrix, convert into a diagonal matrix.
Okay, you're trying to convert it into a diagonal. Yeah, that is also fine. Like
It
that
is
way
also
also.
possible.
Yeah, we can do it like that way also.
Nice.
So, here also you can simply show, see this one, you can clearly see the first one is fine. So the second one also you cannot get by any linear combination, and similarly the third one also, right? There is no linear combination possible. So this you can simply say that all three are linearly independent.
Yes.
But if you completely reduce it, you are getting an identity matrix also from the solution which I have, because I took a question from a book. Mm, now, okay, another question, one last question we will discuss. Okay, so consider the subset S is equal to 3 comma 1. Okay, wait. 3 comma 1 comma minus 1, then 2 comma 2 comma minus 1, then minus 5 minus 2 and 2, then 1 comma 3 comma 1 of 3, that is a three-dimensional list. If a matrix A is having columns as vectors of set S, then here we have given a subset of 3, right? And if A is a matrix having columns as vectors of set S, then we have to see about the linear dependence of S and the rank of A. So this has been given the vector S, and it is telling that A is having these the columns of A are these vectors only. Understood? You have to form a matrix A which has the columns like these only. Then you have to comment about the linear dependence and independence of S, and also about the rank of A. So I will give you 4-5 minutes to solve it. Take 5 minutes, then we will discuss the solution. Okay. So did you get the approach how to do it? How will we solve it? Please put your answers in chat box, everyone, that how we will solve it, because by now you should be clear in like the questions, at least about the approach. Even if you are making calculation mistakes, that will get fine by practice, but at least the approach you should get. So put your answers in chat box that how we will solve this question. This is a simple question. How we will do it? Comment. The question is comment about So the question is that we have to comment about the linear dependence and independence of S and the rank of A. So let me read what you have put in chat box. Reduced RREF form. Yeah, Gifty, but like what we will get from that?
Then we will know the dependency, madam. Linear dependency. Then we can actually we'll find formate matrix A. And if you reduce to this form, then linear
Yes.
dependency we can get, right. Then rank also it will come.
So Ronak, you tell me. Can you, Ronak, unmute yourself and tell me how we will do it? Or if you have any doubt that how we should proceed, then I will help you. So you are doing it the right way. First, we will form a matrix A with these vectors as the columns of the matrix, and then we will find the rank, simply the rank of A. After finding the rank, we can also comment about the linear dependence and independence of S, because the vector A is formed from the S only, na? That is why simply getting the rank of A, if the rank of A is 4, then it is obviously linearly independent. But it is, if it is less than 4, right, then it is going to
So
be,
be a 4, rank 4 will come because it is a 3 by 4 matrix, right?
yeah, sorry, 3 by, it is a 3 by 4 matrix.
So it can maximum come to 3.
So that like, yeah, you have to find the rank of A, and if the rank is less than the minimum of the columns or rows, that here we have 3, then you can say that it is the S is linearly dependent. So try and solve it, then we'll see. Wait a second. Yeah, Kavita. Have you done it?
Yes.
What did you get the answer?
Rank is 3,
Uh-huh.
linearly independent.
Okay, fine. Can you tell me first, second, what matrix did you form?
Actually, I have not did it in a standard form. I first yeah, interchange the row 1 and row 2. Then I proceed.
That like how you can do it that way also.
That is also possible.
Yeah, that is possible. But first, it has been given that these are the columns, right? So we have to form
Yeah.
3,
3,
1, minus 1, then
2, 2,
2,
minus
minus
1,
1, then
minus
minus 5, minus
minus
2,
1, 2,
2,
1, 3,
1.
1.
Okay. 1, 3, 1. So, yeah,
First
Kavita.
row by 3,
We can do that way, but Kavita, which rows did you interchange?
First and second.
First and second. Yeah,
Yes.
you can do that. Simply, you can do that. You can get a 1 there. Then what did you perform? 1, 2, minus 2,
1,
3,
2, minus 2, 3.
3, 2, minus 5, 1,
6.
minus 1, minus 1, 2, and 1.
Okay, okay,
Then
go
what?
down. Then my final answer, ma'am.
Huh.
1, 2, minus 2, 3.
1,
First row.
2, minus 2, 3. Yes.
And second row.
Uh-huh.
0, minus 4.
Uh-huh.
1,
Hmm.
minus 8.
Minus 8. Then,
Then next one 0, 0,
huh?
1,
Huh?
8.
Okay, 1, 8. Then, did
That's
you
all.
try to
It's
make this? 1.
It's a row reduced statement form.
No, still it is not in RREF because,
Second row is having this.
huh?
So second one, the leading entry of the second one is 1, she wants.
This is 1.
This is not RREF because the second row leading entry must be 1.
Yes, so you have to make it in that form only, na, first. So you can do it further. What we will do for that? We will divide the second row by
By
Minus.
minus 4.
-4, right? So we will get this as 1. This will be -1 by 4, right?
Yeah.
Yes.
And this will be
Minus 2.
2.
2.
This will be 2. This will be 0, 1, and 8. So for making the first one 0, we cannot make it 0, right?
So
So
now it is a row reduced statement.
looking at the second and third, wait a second. Huh. Now this is an RREF. We cannot make these two 0. Yeah. So this is an RREF and you can see the rank is 3, right? We are getting the
Yes.
rank as 3. So that is why if the rank is 3, it means what?
Linearly independent.
Linearly independent, right? Okay. So I think we shall like end today's session here, right?
Okay.
And meanwhile you can practice other questions also. And about your doubts, we like you had doubts in which questions, Kavita, you said na initial.
In tutorial 1,
Uh-huh.
I think the 10th question, the options are wrong. I think so.
The 10th question,
Or
which
10.
one? Can you like share it?
Number 10. Share.
Because like I have to check it from my end. Wait a second. My screen is not visible, na?
Yes,
Huh?
not visible.
Wait a second. Let me share it again. Now is it visible?
It's prepared.
Now is it visible?
Yes.
So wait a second. Let me discuss. Which question you're talking about, Kavita? I think this was the previous class, right? And
Not
the
the previous time.
then
I'm
okay,
asking from the tutorial.
assignment.
Sorry, assignment. Sorry, assignment. First assignment.
Yeah. Okay, first assignment, 10th question. I don't have access to that, but can you put the question in chat box? I will check it once, and in next class I'll let you know.
Okay, ma'am. Actually, it is a time.
Huh?
The time 9 o'clock. Okay. It's
Okay.
time to end.
Okay.
Sorry
Okay.
to
Okay.
disturb.
Yeah. Fine. Then we will end this session here only. In the next class we'll meet again. Okay.
Next one, when it will be, madam?
It will be on Friday only. Friday.
All 5 days.
Huh?
All 5 days will be.
Yeah. It will be all Friday 7 to 9.
Okay. Thank you.
Okay. So goodbye.
Thank you. Bye.
Thank you.